There is a layer in the rock. You won't see it with the naked eye. You have to know where to look. You have to understand the language of geological time. You have to understand that the Earth keeps its secrets in chemistry, not in monuments. But if you find it, if you identify it, you will be paralyzed, because this layer, buried 56 million years deep in the past, should not exist the way it does. And when science tries to explain why it's there, the answers don't fully convince. Not everyone, not entirely. It's not a layer of volcanic ash. It's not a trace of a meteorite. It's not the dust from a war between planets. It's carbon, an obscene amount of carbon injected into the atmosphere in a period that, in geological terms, was an instant, a blink, a Tuesday afternoon in the history of the Earth. And its chemical signature, its isotopic footprint, its molecular stamp, is practically identical to what human industrial civilization is leaving on the planet right now. At this very moment, that shouldn't be possible, or it should be, and that's precisely what's terrifying. In 2018, 2 scientists published a paper that almost no one read outside specialized circles. Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, astrophysicist at the University of Rochester, sat in front of their data and asked a question that no serious scientist had formally posed before. A question that sounded like science fiction but was published with methodological rigor in the International Journal of Astrobiology. The question was simple, devastatingly simple. If an industrial civilization had existed on Earth millions of years before us, could we know it had been here? The answer they found kept them awake. Imagine that humanity disappears tomorrow, not due to a war, not with explosions, just a sudden silence. The machines stop, the lights go out, and life is erased from the surface of the planet in a matter of weeks. The world keeps spinning, rivers keep flowing, trees keep growing, but we are no longer here. The clock moves forward 10 million years. A hypothetical geologist arrives at what was once New York, or Shanghai, or Mexico City. He takes rock samples, analyzes them in his lab. What does he find? Frank and Schmidt asked exactly this question and built models to answer it. The results were, in their own words, baffling. In terms of recognizable physical structures, the answer is nothing. Buildings collapse in centuries. Concrete disintegrates in thousands of years. Steel rusts, glass shatters and turns to sand. In 10,000 years, most of the physical evidence of our cities would be gone, swallowed by vegetation, eroded by water, buried under sediment. In a million years, the places where our metropolises once existed would be geologically unrecognizable. And in 50 million years, tectonic plates would have reshaped the planet to the point where even the continents would have changed shape. The ocean floors renew themselves completely every 200 million years. The crust created at ocean ridges eventually gets swallowed by subduction zones. Where it melts back into the mantle, everything on that ocean floor disappears with it. Continental crust is older. Yes, there are rocks on the continents that are almost 4 billion years old, but the exposed continental surface older than 2.5 million years is rare. Erosion, sedimentation, volcanism, and tectonic deformation have constantly rewritten it. Finding an intact surface from 50 million years ago is like finding a needle in a continental haystack. So Frank and Schmidt changed the question. They didn't look for structures, they looked for chemical traces, signatures, anomalies, things that would remain after everything physical disappeared. And they found that an industrial civilization would leave several possible marks. Microplastics accumulated in marine sediments, radioactive isotopes from nuclear tests, which, although they degrade over time, would persist in detectable traces for hundreds of thousands of years. Anomalous concentrations of heavy metals in specific locations, synthetic molecules that don't exist in nature, and, above all, one thing, the most important one, the one that would persist the longest. a massive and rapid disruption in the chemistry of atmospheric carbon, a spike in the geological record where huge amounts of organic carbon, the kind that comes from burning biological materials like coal and oil, were released into the atmosphere in a geologically brief period. A carbon signature that would remain embedded in the chemistry of rocks and ocean sediments for tens of millions of years. And when Frank and Schmidt looked at the deep past's geological record searching for exactly that signature, they found something they could not ignore. They had found it even before they knew they were looking for it. 56 million years ago, something happened to this planet that geologists still can't fully explain. It wasn't a meteor impact. There's no crater. It wasn't a single massive volcanic eruption. There's no caldera large enough. It was something else. Something that came quickly, burned intensely, and left a mark so deep in the geological record that every rock core sample from that era, whether extracted from the bottom of the Atlantic Ocean or drilled from the Arctic permafrost, tells the same story. Scientists call it the Paleocene-Eocene Thermal Maximum, or PETM for short. You've probably never heard of it. It's not taught in schools. It doesn't appear in general interest documentaries, but it should, because the PETM is one of the most extraordinary events in the last 66 million years of Earth's history. And it has one feature that, once you understand it, won't let you sleep. It looks exactly like what we're doing right now. About 56 million years ago, in a geologically brief period of between 5,000 and 20,000 years, an enormous amount of carbon was injected into Earth's atmosphere. The most conservative estimates speak of between 3,000 and 7,000 gigatons of carbon. To put that into perspective, humanity has released about 400 gigatons since the start of the Industrial Revolution. The PETM released between 10 and 15 times more than all of human industrial activity combined, and it did so in a geological instant. The result was catastrophic. Global average temperatures rose by between 5 and 8 degrees Celsius. 5 to 8 degrees. That doesn't sound dramatic until you understand what that means. The current conversation about climate change revolves around avoiding a rise of 1.5 to 2 degrees. 5 to 8 degrees is a completely different planet. During the PETM, the Arctic Ocean reached temperatures of 23 degrees Celsius, equivalent to 73 degrees Fahrenheit, subtropical temperature, off what is now Antarctica. The surface temperatures of the ocean hovered around 20 degrees. The poles had enough heat for palm trees. Relatives of crocodiles lived north of the Arctic Circle. The tropics became nearly uninhabitable. Ocean surface temperatures off the west coast of Africa reached 36 degrees Celsius, a temperature at which many marine organisms simply can't survive. The deep ocean lost much of its oxygen. The creatures living on the ocean floor died in massive numbers. It was the largest deep-sea extinction of the last 93 million years. The oceans acidified dramatically when carbon dioxide dissolved in seawater, forming carbonic acid. Organisms that build calcium carbonate shells, corals, foraminifera, and a vast variety of marine plankton were devastated. Their shells literally dissolved before they could be buried and preserved as fossils. On land, rainfall patterns changed violently. Some regions that had been lush dried up. Others were hit by unprecedented storms. The fossil record shows abrupt changes in plant and animal communities. In the Bighorn Basin in Wyoming, one of the areas with the most detailed terrestrial record of the PETM, the entire mammalian fauna was reorganized. Species disappeared. New species emerged. The landscape was reordered from top to bottom. Mammals did something particularly strange during the PETM. Many species became smaller. Horses, which were already small, became even smaller. Primitive primates, our distant ancestors, shrank in size. This dwarfing event is documented in the fossil record with chilling precision. You can see in the fossilized teeth, sample by sample as you move through time, how species shrink. The dominant hypothesis is that a smaller body dissipates heat better in a hotter world. Another possibility is that plants grown under high levels of CO2, although they grow faster, produce fewer proteins and nutrients, creating selection pressure for smaller metabolisms. The event lasted between 100,000 and 200,000 years. Then, slowly, the planet recovered. The carbon was absorbed, temperatures dropped, the oceans healed. Life adapted and moved on. The scar remained in the rock, a thin band of unusual chemistry between layers of ordinary sediment. Now comes the part that Frank and Schmidt carefully emphasized. The isotopic signature of carbon from the PETM is identical to that of burning fossil fuels. Carbon has two main isotopes, carbon-12 and carbon-13. Plants preferentially absorb carbon-12 during photosynthesis because it is slightly lighter. Therefore, organic carbon, the carbon that comes from living organisms, has a different ratio of carbon-12 to carbon-13 compared to inorganic carbon from rocks or volcanic emissions. When you burn fossil fuels, you're burning ancient organic matter, plants and organisms that died millions of years ago. This organic carbon has exactly the same isotopic signature as living plants, depleted in carbon-13. During the PETM, the carbon isotope ratios in rock layers show a massive spike in carbon-12. The ratio shifts dramatically toward the lighter isotope. In geological jargon, this is called a carbon isotope excursion, and it's exactly what you would see if someone burned massive amounts of organic material or fossil fuels. It's the same signature we are creating right now with our industrial emissions. The rocks from 56 million years ago look chemically identical to what we're doing today. What caused the PETM? Scientists propose several hypotheses, and none are completely satisfactory. The most widely supported explanation involves massive volcanism associated with the North Atlantic igneous province when Greenland and Europe were separating, and huge volumes of magma burned organic-rich sediments, releasing CO2 and methane. Mercury anomalies in the PETM sediments support this, as mercury is a reliable indicator of volcanic activity. Another hypothesis points to the destabilization of methane hydrates on the seafloor, ice structures that trap methane in deep ocean sediments. If ocean temperatures rose even a little, these hydrates could melt, releasing their methane in a cascading feedback loop. A third hypothesis involves orbital forcing, changes in Earth's orbital eccentricity and precession that could have amplified the initial warming. Most scientists today believe the PETM was caused by a combination of these factors, but there's a persistent problem. The amount of carbon required is enormous. The mechanism for releasing it so quickly doesn't fit perfectly with any single explanation, and the isotopic signature, while consistent with organic methane and volcanic carbon, matches suspiciously precisely with fossil fuel burning. Frank and Schmidt were meticulously careful. They explicitly stated that they strongly doubt there was a previous industrial civilization. They were not trying to prove one existed. They were asking if we would know if one had existed. And the disturbing answer they found was that, in many cases, no, we couldn't, because if a civilization had existed and had burned its fossil fuel reserves in a similar way to us, the chemical signature it would have left would be virtually indistinguishable from a natural carbon release event. That's not proof that something was here. It's proof that we can't know if something was here. And in science, that distinction matters. Imagine the world 12,800 years ago. The great ice sheets that had covered much of North America and Northern Europe for tens of thousands of years were retreating. The climate was warming. Mammoths still roamed the tundra. Saber-toothed tigers lurked in the forests. Giant sloths the size of cars grazed in the forests of the Americas. In North America, a culture of skilled hunters was thriving. Archaeologists call them the Clovis people, named after a site near Clovis, New Mexico, where their distinctive spear points were first discovered. These points are beautiful, grooved, symmetrical, lethal. They represent one of the most refined stone technologies in the prehistoric world. The future seemed open, and then, in what appears to be the span of a human lifetime, everything changes. The megafauna disappears, not gradually, not by slow wear over millennia. They disappear. In North America alone, 35 species of large animals go extinct in a geological instant. Mammoths, mastodons, giant sloths, short-faced bears, American lions, saber-toothed tigers, dire wolves, giant beavers the size of black bears, American camels, American horses. All of them, in what the fossil record suggests was a catastrophically sudden event. A 2008 study pointed out that the extinction seems to have been too sudden and extensive for both human hunting and climate change to have been the main cause. The Clovis culture disappears at the same time. Their distinctive tools vanish from the archaeological record. What replaced them was different, simpler, less sophisticated, as if the knowledge that produced those beautiful grooved points had been interrupted, broken, lost, and the climate collapses. Temperatures that had been rising for thousands of years suddenly plummet. In parts of Greenland, annual average temperatures may have dropped between 10 and 15 degrees Celsius in a matter of decades. The warm period ends. Winter returns. The younger Dryas has begun, named after a small Arctic flower, Dryas octopetala, whose pollen suddenly reappeared in European sediments that had previously recorded plants from warmer climates. The conventional explanation points to the sudden cooling of the North Atlantic. The hypothesis is that a massive pulse of fresh water from the melting glaciers in North America, possibly from the catastrophic drainage of Lake Agassiz, a vast glacial lake in the center of the continent, poured into the North Atlantic and disturbed the ocean's thermohaline circulation. This circulation, sometimes called the Atlantic Conveyor, transports warm tropical water northward and is responsible for keeping Europe and the North Atlantic relatively warm. If you suddenly pour enough cold fresh water into the system, the conveyor shuts down. The warm water stops flowing north. Europe freezes. The effects ripple globally. It's a solid theory. It explains much of the data, but it doesn't explain everything. In 2007, a group of about 20 scientists, led by Richard Firestone, Alan West, and others, presented their findings at a meeting of the American Geophysical Union. Their claim was extraordinary. They had found, at multiple sites in North America, a distinct sediment layer dating to about 12,900 years ago that contained an unusual set of materials, nanodiamonds, microscopic diamonds that form under extreme heat and pressure, magnetic microspheres, small metallic balls that form when rock or soil melts and resolidifies in the air, elevated levels of iridium, a rare element on Earth's surface but common in asteroids and comets, fractured quartz grains that show fracture patterns produced only by extreme pressure, the kind associated with nuclear explosions or cosmic impacts, carbon spheres, soot, and evidence of widespread and intense burning. The team proposed that a large, low-density extraterrestrial object, most likely a fragmented comet, exploded over or impacted the Northern Hemisphere about 12,900 years ago. The explosion, they argued, would have been equivalent to thousands or even tens of thousands of nuclear weapons detonating simultaneously. The resulting shock wave, thermal pulse, and firestorm would have devastated life over a vast area. The dust and soot thrown into the atmosphere would have blocked sunlight for months, triggering rapid cooling. The impact on the Laurentide ice sheet in North America could have destabilized the ice, releasing vast volumes of meltwater into the Atlantic and shutting down thermohaline circulation. In a single event, the extinction of the megafauna, the destruction of the Clovis culture, evidence of massive fires, climate collapse, and the shutdown of ocean circulation. One cause, multiple effects. The Younger Dryas impact hypothesis was met with intensity by the scientific community. Critics pointed out that there was no obvious impact crater. Defenders responded that a comet breaking up in the atmosphere, an airburst, would not necessarily leave a traditional crater. The Tunguska event in Siberia in 1908, when a relatively small extraterrestrial object exploded in the atmosphere, leveled 2,000 square kilometers of forest without leaving a crater. Scale that up by orders of magnitude, and you get the Younger Dryas event. The debate continues today. In 2018, researchers discovered the Hiawatha crater in Greenland, a massive impact structure over 30 kilometers in diameter, buried under 900 meters of ice. Initial estimates placed its age at around 12,800 years, right within the Younger Dryas window. Subsequent dating has pushed its age back a bit, and the debate continues as to whether it's related to the event. But its discovery proved that large impacts during this period are not impossible. They are documented. In 2025, researchers published findings of a crater-like depression in Louisiana, nearly 3 kilometers long, caused by what appears to have been a cosmic airburst explosion dating back to approximately 12,800 years ago. The site contained the same markers found at other Younger Dryas boundary locations: nanodiamonds, magnetic microspheres, glass formed at temperatures above 2,000 degrees Celsius. The characteristics matched those found at nuclear test sites in New Mexico and Kazakhstan, where atomic detonations had created virtually identical geological features. But here is where the story takes a turn that matters for our narrative. Because the Younger Dryas impact hypothesis is not just about climate science or extinction events. It's about what was lost. If a cosmic catastrophe struck the Earth 12,800 years ago, what was the state of human civilization at that time? The standard archaeological narrative says that humans in this period were hunter-gatherers, small bands roaming the landscape following herds, living in temporary camps, no cities, no agriculture, no writing, no permanent structures, simple people living simple lives. That narrative has been under pressure for years, and the discovery that shattered it came from a dusty hill in southeastern Turkey, a site that should not exist, a site that, according to everything we thought we knew about human history, is impossible. There's one detail that almost never appears in popular discussions about the Younger Dryas, and it's precisely the one that should open up the debate. The event was not regional, it was global. The impact markers, the nanodiamonds, the magnetic microspheres, the elevated iridium, the fractured quartz have been found at more than 50 sites spread across 4 continents: North America, Europe, the Middle East, parts of South America. A local event doesn't produce that distribution. A local event doesn't wipe out megafauna from continents that don't share the same fauna, climate, or ecosystem. But there's something else that is rarely mentioned: the speed of climate change. In the Greenland Ice Core record, which preserves a high-resolution climate history, the onset of the Younger Dryas appears in such a compressed period that some researchers measure it in decades, not in centuries, not in millennia, in decades. Climatologist Richard Alley from Penn State University has documented that some of the most abrupt climate changes in the Greenland record occurred in periods as short as 3 years. 3 years in which the average annual temperature dropped several degrees and precipitation patterns changed radically. No gradual process produces that. Not the slow melting of a glacial lake, not the gradual cooling of an ocean current, not the slow advance of a cold air front. What produces changes in years or decades are threshold events, systemic collapses where the climate system crosses a point of no return and reorganizes almost instantly into a new state. And cosmic impact events are one of the few known forces capable of pushing the climate system to that threshold so suddenly. Statistics of a large-scale impact or airburst on a continental ice sheet is devastating in specific ways. The instant heat turns the ice into vapor and liquid water simultaneously. The vapor forms massive clouds that block solar radiation. The meltwater, released in huge pulses, pours into the ocean, altering its density and salinity, and the dust, the soot from the continental fires triggered by the thermal pulse of the impact, forms a veil in the stratosphere that can persist for months or years, reducing global surface temperatures with the same logic as a nuclear winter. In 2025, when the researchers published their findings from the site in Louisiana, what stopped them was the temperature match. The glass formed at the site required temperatures above 2,000 degrees Celsius. The only direct comparison available in the scientific literature was the nuclear test sites in New Mexico and Kazakhstan, where atomic detonations had produced virtually identical geological features. No volcanic eruptions, no lightning strikes, nuclear tests. That doesn't mean something nuclear happened. It means that the energy involved in the event was of that order of magnitude. Consider what that implies for any human settlement in the Northern Hemisphere 12,800 years ago. It wasn't a threat to run away from. It was an instantaneous reorganization of living conditions across an entire continental region. People living in temporary camps could move. People living in permanent structures, in organized communities, in places with accumulated infrastructure, had nowhere to go in the time span that the event gave them. What the Younger Dryas erases from the archaeological record is not just a culture. It is an entire window of human possibility, the period just before the climate stabilized enough for agriculture to emerge, for cities to be built, for civilization, in any recognizable sense, to be consolidated. If something was developing in that period, if there was something more sophisticated than the hunter camps the archaeological record shows us, the Younger Dryas event would have been precisely the kind of disruption capable of erasing it. Not completely, not everywhere, but enough that what remained, from our current perspective, would look like a beginning, not a continuation. And there's one last detail worth emphasizing. The Younger Dryas was not the only event of abrupt cooling in the post-glacial period. The climatic record of the last 20,000 years is marked by a series of oscillations known as Dansgaard-Oeschger events, cycles of rapid warming and cooling that repeat with disturbing frequency. The Younger Dryas was the most recent and the most severe. But it wasn't unique. The planet has gone through periods of extreme climatic instability with a regularity that should make us more humble about what we consider normal conditions for habitability. The climatic stability that allowed the rise of agriculture, cities, writing, and everything we call civilization began about 11,600 years ago. That's not a fixed starting point in the history of human intelligence. It's the beginning of the last period of calm on a planet whose climate, if you look at it on a geological scale, is anything but stable. Southeast Turkey, the Taurus Mountains, a landscape of rolling hills, dry under a wide sky, 15 kilometers northeast of the ancient city of Şanlıurfa. A hill rises gently from the surrounding land. It's not natural, it's a tell, an artificial mound created by thousands of years of overlapping human activity. Locals call it Göbekli Tepe, the hill of the navel. For centuries, farmers worked the soil around it, occasionally finding worked stones and fragments of carved rock, which they piled along the edges of their fields and forgot about. In 1963, a joint survey team from Istanbul University and the University of Chicago visited the site. They noted the worked stones. They recorded it as a medieval cemetery. They moved on. For 31 years, one of the most important archaeological discoveries in human history was in plain sight, discarded and ignored. Then, in 1994, came a German archaeologist named Klaus Schmidt. Schmidt had been working at another ancient site in the region, Nevellichori. When locals directed him to the hill, he immediately recognized the stone fragments. These weren't medieval. They were prehistoric, and they were old, very old. He began excavating in 1995. What emerged from the earth was so extraordinary that it took years for the archaeological world to fully understand what had been found. Limestone pillars in the shape of Ts, some nearly 5 meters tall, some weighing up to 20 tons, arranged in circles, embedded in walls of smaller stones and covered with intricate carvings. Foxes, lions, wild boars, snakes, vultures, scorpions, abstract symbols, and on some pillars, arms carved in relief running down the sides of the stone with hands meeting at the front, as if the pillars were stylized representations of human beings. Giant stone people standing in circles facing the darkness. The circles are massive. The largest measures approximately 20 meters in diameter. Each enclosure contains 2 taller and more elaborately carved central pillars than the surrounding ring. 20 enclosures have been identified so far, although studies indicate that many more remain buried. Only a fraction of the site has been excavated. The dating is what shattered the textbook narrative. Radiocarbon analysis placed the oldest structures at Göbekli Tepe at around 9,500 BCE. That's 11,500 years ago. More than 6,000 years before Stonehenge. More than 6,000 years before the Egyptian pyramids. Older than any known permanent human structure. Let that sink in. 11,500 years ago. That's before agriculture, before pottery, before metalworking, before the wheel, before writing, before every element of what we traditionally define as civilization. The people who built Göbekli Tepe were, according to every other line of evidence, hunter-gatherers. They had no domesticated plants. They had no domesticated animals. They had no permanent villages. They had no written language. And yet, they built this. They quarried limestone blocks up to 20 tons in weight from outcrops hundreds of meters away. They shaped these blocks into precise T-shapes using nothing but flint tools. They carved elaborate animal reliefs into the hard stone, work that required not only skill but also artistic sophistication and high-level symbolic thinking. They transported these massive pillars to the top of the hill, erected them in carefully planned circular arrangements, and oriented them precisely. Computational modeling, led by researchers and published in the Cambridge Archaeological Journal, revealed that the builders used geometric principles to plan the layout. The 3 main enclosures are connected by an equilateral triangle, suggesting that the entire complex was conceived as a unified design rather than a series of separate structures added over time. The builders stretched ropes to measure distances and establish angles. They worked with a level of planning and coordination that implies organizational sophistication far beyond what was previously attributed to hunter-gatherer societies. Then they did something even more mysterious. Around 8000 BCE, they deliberately buried the site. They didn't abandon it and let nature reclaim it. They actively filled it with earth, debris, and waste, as if sealing it, protecting it, or hiding it. Why, no one knows for sure. Without this intentional burial, 12,000 years of erosion, earthquakes, and weathering would have reduced the site to rubble. The burial was, intentionally or not, an act of preservation. Göbekli Tepe means more than just an archaeological curiosity. It means the collapse of a model. Before this discovery, the accepted sequence of human development was first agriculture, then villages, then temples. Göbekli Tepe reversed all of that. The temple came first, long before anyone in the region had domesticated a single grain of wheat, long before anyone had penned in a sheep or planted a row of barley. Klaus Schmidt suggested that the construction of Göbekli Tepe required such a large workforce that the need to feed those workers drove people toward the deliberate cultivation of wild grains. Building the temple created the need for agriculture, not the other way around, and there is evidence to support this. Just 30 kilometers from Göbekli Tepe, geneticists found the oldest domesticated strains of wheat in the world. Radiocarbon dating places this domestication at around 10,500 years ago, just 500 years after the construction of Göbekli Tepe began. The cradle of agriculture and the world's oldest temple are neighbors, but the alternative interpretation is even more unsettling. What if Göbekli Tepe is not the beginning of something? What if it's the end? What if the knowledge, organizational skill, architectural sophistication, and symbolic language carved into those pillars didn't arise from nowhere in the minds of nomadic hunters? What if it was inherited, passed down from an earlier tradition, an earlier culture, a previous level of human achievement that was destroyed or disrupted by the catastrophe at the end of the Ice Age? The temporal alignment is hard to ignore. The Younger Dryas ended about 11,600 years ago. The oldest structures at Göbekli Tepe date to about 11,500 years ago. The gap is 1 century. It's as if the moment the cold released its grip and the world began to warm again, someone immediately started building urgently with a level of skill and knowledge that suggests they didn't invent it at the time. They already had it. On one of the most famous pillars at Göbekli Tepe, Pillar 43, also known as the Vulture Stone, is carved a complex scene. A vulture holds a round object, possibly a sphere or a head. Below, a scorpion. Around it, other animals and abstract symbols. Researchers from the University of Edinburgh have proposed that the carvings encode astronomical information, that the animals represent constellations, that the round object represents the sun, and that the scene represents a specific moment in time, a date encoded in stone using the positions of the stars. The date they propose is around 10,950 BCE, right at the onset of the Younger Dryas. If this interpretation is correct, and it is still debated, then Göbekli Tepe is not just a temple, it's a memorial, a stone-engraved record to commemorate a catastrophe, a message from the survivors of something terrible left for the future, a way to say, we remember what happened, we remember the fire from the sky. We now travel to Egypt, to the Giza Plateau, to the most famous monument on Earth, the Great Sphinx, a limestone body the size of a building, a human head on a lion's torso, carved from the living bedrock of the plateau, not built block by block like the pyramids, but excavated downward from the surface, freed from the surrounding rock. According to conventional Egyptology, the Sphinx was carved around 2500 BCE during the reign of Pharaoh Khafra, who also built the second largest pyramid at Giza. The evidence for this dating is largely circumstantial. There is no inscription on the Sphinx naming its builder. The attribution to Khafra rests on its proximity to his pyramid, its stylistic similarity to Old Kingdom art, and a damaged stele between its paws that may reference Khafra's name, though the relevant part of the text is eroded and fragmentary. For most of the 20th century, this dating was not seriously questioned. Then, in 1990, a geologist walked into the Sphinx enclosure and saw something that shouldn't have been there. His name was Robert Schoch. He had a PhD in geology and geophysics from Yale. He was an associate professor at Boston University. He was not an Egyptologist. He was not a mystic. He wasn't looking for lost civilizations. He had been invited to Egypt by independent researcher John Anthony West, who had long suspected that the Sphinx was older than the official dating. West wanted a geologist to look at the rock. Schoch went, expecting to confirm the conventional date. It took him seconds to see the problem. The walls of the Sphinx enclosure, the trench carved into the bedrock when the Sphinx's body was freed from the surrounding stone, showed deep, rounded grooves, undulating surfaces, cracks that were wider at the top than at the bottom. The profiles were unmistakable to a trained geologist. They were the product of water erosion, specifically rainfall erosion, water running down vertical surfaces over extended periods, carving rounded channels and dissolving limestone from above. The problem is that the Sphinx is at the edge of the Sahara Desert. The Giza Plateau has been essentially arid for the past 5,000 years. Precipitation in the region is minimal. The dominant weathering agent on the plateau is wind and sand, which creates a very different erosion pattern. Wind erosion creates horizontal striations, sharp edges, and angular profiles. The surfaces on the walls of the Sphinx enclosure didn't look like that. They looked as if they had been battered by centuries of heavy rain. Schoch examined other structures on the Giza Plateau that were securely dated to the Old Kingdom era. Nearby tombs, carved from the same geological formations, showed erosion consistent with wind and sand, sharp horizontal layers, angular surfaces, desert weathering. The Sphinx and its enclosure showed something completely different. Deep vertical grooves, rounded surfaces, water damage. If both structures were carved at the same time from the same rock under the same climate, they should show the seep and erosion patterns. They don't. The simplest explanation, Schoch argued, is that they were not carved at the same time. The Sphinx was much older, old enough to have been exposed to a period of sustained heavy rainfall. When did Egypt experience that kind of rain? During the African humid period, roughly between 12,000 and 5,000 years BCE, the Sahara was not a desert. It was a green savanna. Lakes dotted the landscape. Rivers flowed where now only sand remains. Rainfall was abundant. Rock art in what is now the deep Sahara shows people swimming, herding cattle, and living by waterways that no longer exist. Schoch initially estimated the construction of the Sphinx before 5000 BCE. Later, as his research continued, he pushed his estimate further back, suggesting that the core body of the Sphinx could date from the end of the last ice age, around 10,000 BCE, or perhaps even earlier, a date that would make the Sphinx not 4,500 years old, but 12,000 years old, possibly more. The response from conventional Egyptology was predictable. Archaeologist Mark Lehner, one of the world's leading authorities on the Giza Plateau, rejected the hypothesis. Counter-arguments pointed out that the erosion could be explained by salt weathering, by the periodic soaking from the Nile floods, by moisture absorbed from the sand that periodically buried the Sphinx. Geologist James Harrell of the University of Toledo proposed that rainwater filtering through porous sand that covered the Sphinx for thousands of years could produce similar erosion patterns without requiring a wetter climate. These counter-arguments have merit. The geology of the Giza Plateau is complex. Multiple weathering processes operate simultaneously, but Schoch conducted seismic studies around the base of the Sphinx, using hammer strikes on steel plates to generate sound waves that penetrated the rock. The reflected signals revealed the depth of subsurface weathering, how deeply into the rock the erosion extended. The data showed extraordinary depth, deeper than expected for a monument only 4,500 years old, and the depth was consistent across the entire enclosure, suggesting prolonged, uniform weathering from above. Rain, not localized flooding. He also pointed out a detail that is hard to ignore. The head of the Sphinx is smaller than the body, disproportionately so. Precise measurements confirm this. The head is too small in relation to the size of the body, and the tool marks on the head are relatively recent, consistent with Old Kingdom craftsmanship. This led Schoch and others to propose that the head was recarved, that the original head, whatever it had represented, had been so damaged by weathering that a later pharaoh recarved it into its current form. A smaller head carved from a larger eroded original would explain both the disproportionate size and the different tool patterns. The body had endured thousands of years of rain. The head was freshly carved around 2500 BCE and has only experienced desert conditions since then. There is another observation that adds to the mystery. The Sphinx faces directly east. On the morning of the spring equinox, it faces the rising sun. But due to a phenomenon called precession, the slow wobble of Earth's axis over a cycle of about 26,000 years, the constellation visible on the eastern horizon at sunrise during the equinox changes over time. Today, the constellation is Pisces. 2,000 years ago, it was Aries. 4,000 years ago, around the time when Egyptologists date the Sphinx, it was Taurus, the bull. But if you rewind the sky to around 10,500 BCE, the constellation rising on the eastern horizon at the spring equinox was Leo, the lion. A monument of a lion facing east, contemplating the constellation of the lion at dawn on the equinox. The alignment is precise, the symbolism is obvious, and the date falls exactly within the window that Schoch proposed for the original construction of the Sphinx. The debate about the Sphinx remains unresolved. Conventional archaeology assigns the monument to the reign of Khafra. The geological evidence at least raises questions that have not been satisfactorily answered, and the broader implications are enormous. If the Sphinx is 12,000 years old, it means that someone was in Egypt at the end of the Ice Age with the knowledge, organization, and motivation to carve a monumental sculpture from the bedrock. Who were they? Where did they come from? What else did they build? And if a catastrophe swept the world at the end of the Ice Age, what happened to them? The controversy over the Sphinx doesn't end with geology. It branches out in multiple directions, and each branch leads to a question that conventional Egyptology would prefer not to answer directly. Let's first take the issue of repair. It is an archaeologically documented fact that the Sphinx has been restored and patched up multiple times throughout its known history. Pharaoh Thutmose IV, around 1400 BCE, placed a stele between its paws that describes how the monument was half buried in sand at that time and promised to uncover it in exchange for gaining the throne. Pharaohs of the Ptolemaic period made additional repairs. At various times, the Sphinx was covered up to its neck by accumulated sand, which paradoxically preserved it from weathering, but also makes it impossible to know for sure what conditions it experienced during periods when it was exposed. This complicates Schoch's geology in a specific way. If the Sphinx was buried in sand for long periods and exposed at other times, the erosion patterns we see today are the sum of intermittent exposure episodes, not a continuous sequence. But the depth of weathering that Schoch documented in his seismic studies doesn't fit with intermittent exposure under arid conditions. The depth implies prolonged, uniform weathering, the kind produced by sustained rainfall, not wind or periodic moisture from the sand. There's another angle that is rarely mentioned in popular discussions: the geology of the plateau itself. The limestone of Giza is not uniform. It has layers of varying hardness and porosity, and the Sphinx was carved through several of these layers. Some are more resistant to water, others are more susceptible. The erosion patterns on the Sphinx are not uniform across its height, which complicates both the conventional hypothesis and Schoch's. Some layers show deeper erosion than others, which could indicate multiple periods of different conditions or simply reflect the varying resistance of the rock layers. The most sophisticated counter-argument to Schoch doesn't come from Egyptology, but from another geologist. Farouk El-Baz, a geologist at the Remote Sensing Center of Boston University and former NASA scientist, has pointed out that in North Africa there is a phenomenon called dew and fog precipitation that can deposit moisture on rock surfaces even in very arid conditions. Over decades and centuries, the accumulation of cycles of moisture and drying from dew can produce chemical weathering on the limestone that superficially resembles rain erosion. It's not identical, but it can be confused with it. Schoch rejects this argument by pointing to scale. The depth of weathering he documented in his seismic studies, which in some places reaches several meters into the bedrock, simply cannot be produced by dew. Dew affects the outermost surface layers. Deep weathering requires water that penetrates under pressure, and that requires intense, sustained rainfall. What makes this debate especially frustrating is that its resolution depends on data that is currently unavailable. To resolve the question definitively, you would need direct dating of the Sphinx's surface using techniques like cosmogenic isotope exposure or thermoluminescence. methods that measure how long a surface has been exposed to solar radiation or heat. These techniques have been applied in many archaeological contexts. They have not been systematically applied to the Sphinx. Egyptian authorities have historically been restrictive with permits for these kinds of non-invasive analyses. Why exactly there has been no institutional willingness to resolve this question with the tools available is something independent archaeologists often point out. Not as proof of conspiracy, but as a methodological curiosity in a discipline that normally embraces new dating techniques. There is also the regional context that is rarely incorporated into the debate about the Sphinx. The African humid period, also called the Green Sahara period, is extraordinarily well documented. Pollen records, lake deposits, rock art, sedimentation patterns, everything converges on the same picture. North Africa between 12,000 and 5,000 years ago was radically different from what it is today. In what is now the Deep Sahara, there is evidence of lakes that were comparable in size to the Great Lakes of North America. Rivers flowed where now there are only dunes. The fauna included hippopotamuses, crocodiles, and elephants in areas that are now completely inhospitable. If the Green Sahara period ended gradually between 7,000 and 5,000 years ago in North Africa, and if the Sphinx was built 4,500 years ago, as conventional Egyptology claims, then the Sphinx was built under conditions that were already essentially arid. Rain erosion of the magnitude that Schoch proposes would have been minimal by that point. For the erosion to be consistent with the Green Sahara period, the Sphinx must predate the end of that period, which pushes its construction to before 5000 BCE at the very least. This doesn't require an advanced civilization, but it does require that there was a human organization in Egypt between 7 and 12,000 years ago capable of planning and executing a monumental engineering project. Whatever that implies about the state of human development at that time, it doesn't fit easily with the standard image of scattered bands of hunter-gatherers. In 1929, in the basement of the Topkapi Palace in Istanbul, a German theologian named Gustav Adolf Deissmann was sorting through old documents and artifacts at the request of the Turkish government. The palace had been the administrative center of the Ottoman Empire for centuries, and its archives contained thousands of uncatalogued items, maps, manuscripts, letters, administrative records, everything piled up in storage and largely forgotten. Deissmann pulled an animal hide scroll from a dusty shelf. It was gazelle leather, dry and aged. He carefully unrolled it. What he found was a map, a fragment, clearly about 1/3 of what had once been a larger chart. But even as a fragment, it was extraordinary. The map had been drawn and signed in 1513 by an Ottoman admiral and cartographer named Hacı Ahmed Muhyiddin Piri, known to history as Piri Reis. He was an experienced sailor, a former corsair who had served in the Ottoman Navy, and a devoted collector of geographic knowledge. In his own notes on the map, written in Ottoman Turkish, Piri Reis explained that he had compiled his chart from about 20 different source maps. 8 were Ptolemaic maps based on the geographic knowledge of the ancient Greeks. 4 were Portuguese charts of recent explorations. 1 was an Arabic map. And 1, Piri Reis claimed, was drawn by Christopher Columbus himself, a map that has since been lost to history. The map shows the west coast of Africa, the Iberian Peninsula, and the east coast of South America, with remarkable detail for its time. But the feature that catapulted Piri Reis's map into the world of mystery and controversy is at the bottom of the fragment, below the South American coast. The map depicts a landmass, a large, continuous landmass extending southward and curving eastward, a landmass that, to some eyes, closely resembles the northern coast of Antarctica. The problem is obvious. Antarctica wasn't officially discovered until 1820, over 300 years after Piri Reis drew his map. The mystery deepened when, in 1965, Professor Charles Hapgood of the University of New Hampshire published a book titled Maps of the Ancient Sea Kings. Hapgood and his students had studied Piri Reis's map in detail and found several anomalies. The map seemed to use a form of Mercator projection, a method for representing the curved surface of the Earth on a flat map, which European cartographers didn't widely adopt until later in the 16th century. And the most striking claim, Hapgood argued that the southern landmass not only represented Antarctica, but it represented Antarctica without its ice cap. The coast shown on the map, he said, corresponded not to the ice-covered coast visible today, but to the actual rocky coastline buried beneath thousands of feet of glacial ice, a coastline that was only mapped by modern technology, seismic studies, and satellite imagery in the 20th century. If Hapgood was right, the implications were astounding. Someone, at some point in deep prehistory, had mapped the coastline of Antarctica before it was covered by ice. That someone possessed the navigational skills to reach the continent, the cartographic abilities to map it accurately, and the means to pass that knowledge forward through time until it eventually reached Piri Reis through a chain of source maps. However, the story is more complicated than the mystery enthusiasts would have you believe. Critics of Hapgood's interpretation have raised serious objections. First, the identification of the southern landmass as Antarctica is far from certain. Many historians of cartography argue that what Hapgood identified as the Antarctic coast is actually a distorted representation of the southern coast of South America. In the early 16th century, the full extent of South America's southern coastline was still unknown. Cartographers routinely extended coastlines based on speculation, rumor, or the assumption, inherited from classical Greek geography, that a large southern landmass must exist to balance the northern continents. This hypothetical terra australis incognita appeared on many maps of the time, long before anyone had actually seen Antarctica. Piri Reis may simply have followed this convention. Second, Hapgood's claim that the map shows Antarctica without ice has been questioned by later research. Modern ice data shows that Antarctica has been covered by ice for at least 10 million years, much longer than Hapgood had assumed. His belief that Antarctica was ice-free as recently as 4000 BCE was simply wrong. Third, the map's own annotations undermine the Antarctic interpretation. Near the southern landmass, Piri Reis wrote that the land was uninhabited, that everything was ruined or barren, and that it was said to contain great snakes. He also noted that the region was said to be very hot. This description doesn't fit Antarctica by any stretch of the imagination. It fits much more naturally with the tropical or subtropical coast of South America. Is Piri Reis's map evidence of a lost civilization with advanced cartographic knowledge? Almost certainly not. The academic consensus is that the map is a remarkable but ultimately explainable product of early 16th century cartography compiled from a mix of contemporary and older sources that contains the typical errors and speculations of its era. And yet, Piri Reis's map is not the only anomalous map from this period. Orontius Phineas's 1531 map also depicts a southern landmass with features that some have compared to Antarctica. Bausch's 1739 map shows what appears to be a southern continent divided by waterways, which some have compared to Antarctica's subglacial topography. Each of these maps has been explained by conventional cartography as variations on the Terra Australis tradition, but the recurring question persists. Why do so many early maps include a southern landmass? Is it all Greek philosophical speculation passed down through the centuries? Or is there, buried somewhere in the chain of source maps that Piri Reis and others used, a fragment of knowledge that is older and stranger than anyone is willing to admit? The honest answer is that we don't know. Piri Reis's map is the most famous of the anomalous maps, but its fame has obscured something important. It's not alone. There is a set of maps from the 15th to 18th centuries that share characteristics which, taken individually, are explainable, but when considered together, point to a cartographic tradition whose sources have not been fully identified. The 1531 map by Orontius Phineas deserves particular attention. Phineas was the royal cosmographer at the French court, not an amateur. His world map, published in Paris shows a continental landmass in the southern hemisphere that is approximately the right size for Antarctica, with a general shape that some researchers have favorably compared to the actual coastline of the continent. What stands out is not just the shape, but the absence of ice in the representation. The continent shown by Phineas has rivers, valleys, and a defined coast, not the uniform ice cap that would be expected if he were simply inventing a southern landmass following the Terra Australis Convention. Proponents of the conventional explanation point out that Phineas may have taken the general outline of Terra Australis from earlier maps and simply filled in the details with cartographic imagination. This is plausible. The cartographers of the time had license to speculate about undiscovered lands. But there is a third map that belongs to this conversation and is almost never mentioned in the context of the debate over lost civilizations. The 1339 map by Dulcet. This Portolan map shows the Mediterranean and Atlantic coasts with remarkable accuracy for its time, including the correct location of the Canary Islands, rediscovered by Europeans in the same period. The problem is that the accuracy of its scale and orientation requires the use of something akin to a cartographic projection that 14th century Europeans did not formally use. Medieval Portolan maps were empirical, built from accumulated navigational data, but the internal consistency of Dulcet's map suggests a level of coordination and data correction that goes beyond the mere accumulation of navigational notes. The question this raises is not dramatic. It does not require invoking lost civilizations, but it does require recognizing that there is a transmission chain of geographical knowledge whose original sources have not been fully identified. Piri Reis explicitly recognized this when describing the sources of his map. 8 of them were Ptolemaic maps, that is, maps based on Ptolemy's 2nd century knowledge of the Common Era, and Ptolemy's knowledge, in turn, was based on earlier sources that did not survive. The Library of Alexandria was destroyed in stages over several centuries, with significant losses during the late Ptolemaic period, the Roman period, and the Arab conquest. What it contained at its peak around the 3rd century BCE is impossible to know for certain. Ancient accounts suggest it housed hundreds of thousands of scrolls, including texts on navigation, geography, and astronomy, from traditions that included Egyptian, Babylonian, and possibly even older traditions. The mathematician Eratosthenes, who was the director of the library in the 3rd century BCE, calculated the Earth's circumference with remarkable precision using shadows and angles, suggesting a conceptual framework of global geography that goes beyond what we typically attribute to that period. What this suggests is not that the Greeks had satellites. What it suggests is that ancient geographic knowledge of the world was more sophisticated and more widely distributed than the surviving record indicates, and that the surviving record is, by definition, what survived thousands of years of loss, destruction, and deliberate forgetting. There is another aspect of anomalous maps that deserves to be developed: the representation of the Arctic. The Zeno map, published in Venice in 1558, but supposedly based on 14th century navigational materials, shows Greenland and the northern Arctic islands with a precision that does not match the official knowledge of European navigators of that period. The map shows the northern coast of Greenland free of ice, with rivers and geographical features. Critics argue that the Zeno map is a partial 16th century fabrication. Proponents point out that it contains details of Greenland's subglacial topography that were not verified until the 20th century. None of these maps, individually, constitute evidence of a prehistoric advanced civilization. Each one has a conventional explanation that is more parsimonious and likely correct, but the set of them raises a question that does not go away. Where did the geographical knowledge that Renaissance cartographers used as a starting point come from? How much of what they compiled was truly new, and how much was the recovery of something that had already existed and that time had fragmented until it became almost unrecognizable? The history of knowledge is not a straight line upward. It is a series of accumulations and losses, of incomplete transmissions and rough reconstructions. Civilizations that believed they were starting from scratch were often starting from the fragments of something earlier. A man in the Turkish city of Derinkuyu is renovating his house. He lifts a mallet and strikes it against a basement wall. The stone crumbles. Behind it is darkness. Not the darkness of a tracking space or a shallow cellar, a deeper darkness, a passage. He makes his way through the rubble and finds himself at the entrance of a tunnel. The tunnel leads to a room. The room leads to another tunnel. That tunnel leads to another room, and another, and another. Descending, going down. What this anonymous homeowner had broken through was one of the most extraordinary archaeological discoveries of the 20th century, a complete underground city carved into the soft volcanic rock of the Cappadocia region, stretching about 85 meters, roughly 280 feet, into the earth, 18 levels deep, with ventilation shafts, water wells, storage rooms, stables, warehouses, wine presses, oil presses, kitchens, meeting halls, schools, and chapels. Massive circular stone doors, each weighing several hundred pounds, could be rolled across the entrances of the corridors from the inside, sealing the city against intruders. The doors could not be opened from the outside. The city was designed for defense, for hiding, for survival. Derinkuyu could house up to 20,000 people, along with their livestock and food supplies for extended periods. The engineering is meticulous. The ventilation system, a network of shafts running from the deepest levels to the surface, provided fresh air throughout the complex. Some of these shafts also functioned as water wells, reaching down to the water table and supplying drinking water to the inhabitants. The air circulation was so well designed that even in the lowest levels, the atmosphere remained breathable. The narrow corridors, deliberately narrow, ensured that invaders would have to move in single file where the defenders could eliminate them. Each floor could be sealed independently. If the upper levels were breached, the population could retreat deeper, closing stone doors behind them. The design reflects military thinking, strategic thinking, the thinking of people who had survived attacks before and were trying to survive again. Derinkuyu is not alone. Cappadocia contains over 200 known underground settlements. Kaymakli, another vast underground city, is just 8 kilometers away. Some researchers believe the two cities were once connected by a tunnel that stretched nearly 9 kilometers between them, creating an underground network. In 2015, during the construction of a housing project near the city of Nevşehir, another underground city was discovered beneath a castle on a hill. Initial studies suggested that it could be even larger than Derinkuyu, extending more than 100 meters in depth and covering nearly 460,000 square meters. Less than half of Derinkuyu itself has been excavated. The conventional archaeological explanation for these underground cities is straightforward. Cappadocia lies at a crossroads of ancient empires. Hittites, Persians, Greeks, Romans, Byzantines, Arabs, Mongols, and Ottomans all fought for control of the region for thousands of years. The underground cities served as refuges during invasions. Historical records confirm this use during the Arab-Byzantine wars of the 8th to 12th centuries, during the Mongol raids of the 14th century, and even into the 20th century, when Cappadocian Greeks and Armenians used the tunnels to escape persecution. The earliest construction is generally attributed to the Phrygians, who inhabited the region in the 8th and 7th centuries BCE. Later groups, particularly Byzantine Christians, expanded the complexes enormously, adding chapels, deeper levels, and sophisticated defensive features. This explanation is rational. It is well supported by archaeological evidence, but it does not answer all the questions. The first question is about scale. Carving a city for 20,000 people, 18 levels deep into solid rock, even soft rock, is an extraordinary engineering feat. Someone had to design the ventilation system before the first shaft was dug. Someone had to calculate the structural loads to prevent collapse. Someone had to map the water table to know where to place the wells. Someone had to coordinate the work of hundreds or thousands of people over what must have been decades, if not centuries, of continuous excavation. This is not the work of terrified villagers digging a hole to hide in. The second question is the most provocative. What were they hiding from? The standard answer is invading armies, and for the historical periods we know, that answer is sufficient. But the extreme depth of Derinkuyu makes you think. You don't need to go 18 levels down to hide from a cavalry raid. A few levels would be enough. The extreme depth suggests that whoever designed the deepest levels was preparing for something more than just a passing army. They were preparing for a scenario where the surface would be uninhabitable for an extended period. Some alternative researchers have linked the underground cities of Cappadocia to the Younger Dryas event. Göbekli Tepe is only 600 kilometers to the east. Both regions were inhabited during the same period. If a cosmic catastrophe struck the northern hemisphere 12,800 years ago, filling the sky with dust and debris, triggering fires and extreme cold, then going underground would be a logical survival strategy, not from human enemies, from the sky itself. This theory is speculative. There is no direct archaeological evidence linking the deepest levels of Derinkuyu to the Younger Dryas or any cosmic event, but the theory persists because it addresses the question of scale. Why dig so deep unless you had a reason to fear the surface itself? There is another possibility. Cappadocia is a volcanically active region. The soft tuff that made the underground cities possible was produced by ancient volcanic eruptions. The people of the region would have been intimately familiar with the dangers of volcanism, ash falls, pyroclastic flows, and toxic gases. Going underground during a volcanic event is a rational response, and digging deep enough to survive a sustained eruption that could cover the surface with ash for months or years could explain the extreme depth of the complex. Whatever the original motivation, the underground cities of Cappadocia represent something remarkable. They represent a civilizational response to existential threat, not just individual survival, not just a family hiding in a cave, a whole community organized, provisioned, and engineered to survive underground for extended periods. They represent the understanding that sometimes the surface is not safe, and that understanding resonates through one of the most persistent and widespread stories in all of human culture. Almost every culture on Earth tells a story about the end of the world, not a future apocalypse. A past one, a time when the water came and swallowed everything, a time when the gods decided to start over, a time when, from the rubble, a handful of survivors rebuilt and began again. The most famous version in the Western world is the story of Noah. But it's not the oldest. The oldest written account of the flood comes from ancient Sumer, the civilization that arose in southern Mesopotamia, in modern-day Iraq, about 5,000 years ago. In the Sumerian king list, one of the first historical records ever compiled, the kings of the pre-flood world are listed with impossibly long reigns. Then comes a single line. The flood swept everything away. The kingship descended again from the sky. A new line of kings begins. In the Epic of Gilgamesh, the greatest surviving work of ancient literature, the hero Gilgamesh travels to the end of the world to find Utnapishtim, the only man ever granted immortality by the gods. Utnapishtim tells Gilgamesh how he survived the Great Flood. The gods of Sumer decided to destroy humanity, but one god, Ea, secretly warned Utnapishtim, speaking through the wall of his reed house. "Tear down your house," said Ea. "Build a boat. Fill it with the seed of all living beings." Utnapishtim built the boat. The storm came. It roared for 6 days and 7 nights. The waters rose until even the gods were terrified. When the storm passed, the boat settled on a mountain. Utnapishtim sent out a dove. It returned. He sent out a swallow. It returned. He sent out a raven. It did not return. The waters receded. The world began again. The parallels with Noah are unmistakable. The divine warning, the great boat, the catastrophic flood, the preserved animals, the landing on the mountain, the birds sent to search for dry land. Scholars have long recognized that the Genesis account was influenced by the older Mesopotamian tradition. The earlier Atrahasis epic, dating from around the 18th century BCE, tells a similar story. The Sumerian Genesis from Eridu provides another version. The flood story was central to Mesopotamian culture long before it entered the Hebrew Bible. But here is what matters for our story. The Mesopotamian flood stories are not unique. They're not even unusual. They are an expression of a narrative that appears in virtually every culture on every inhabited continent. In Hindu tradition, the god Vishnu warns the sage Manu of an impending flood. Manu builds a boat, fills it with seeds and animals, and survives. The boat is pulled through the rising waters by a giant fish. After the flood, Manu makes a sacrifice, and from the offering, a woman emerges. Together, they repopulate the world. In Greek mythology, Zeus decides to destroy humanity with a flood. Deucalion and Pyrrha, the only righteous couple, survive in a chest that floats on the rising waters. When the flood recedes, they land on a mountaintop and repopulate the earth by throwing stones over their shoulders, which turn into new people. In Chinese mythology, the sage Gun tries to stop a great flood by building dams, but he fails. His son Yu succeeds by dredging channels to divert the waters. The flood is a foundational event in Chinese civilizational memory. Among Australian Aboriginals, flood stories are among the oldest oral traditions on the planet. The stories describe a great water that covered the earth, reshaping the coastlines and drowning entire regions. Some of these accounts correspond with geological evidence of rising sea levels after the Ice Age, and researchers have suggested they may preserve memories of real events dating back 10,000 years or more. In the Americas, flood myths are ubiquitous. The Hopi tell of a world destroyed by water because the people had become corrupt. The Aztecs describe a fourth sun, a fourth era of the world that ended in catastrophic floods. The Mayan Popol Vuh describes the destruction of a previous creation by a great flood sent by the gods. Scholars have catalogued over 500 distinct flood myths from cultures all over the world. Many of these cultures had no known contact with each other. They spoke different languages. They lived in different environments. They had different religions, different social structures, different technologies, yet all tell essentially the same story. The world was destroyed by water. A few survived. Civilization began anew. The conventional explanation is cultural convergence. Floods are a universal human experience. Almost every human settlement in history has been built near water, rivers, lakes, coasts, because water is essential for survival, and water inevitably floods. Every culture that lives near water has experienced catastrophic floods at some point. These local disasters are mythologized over generations, growing in scale and importance until they become creation narratives. This explanation has considerable merit, but it doesn't explain the specificity of the parallels. Many flood myths share structural details that go beyond a generic flood narrative. A divine warning, a chosen survivor, a vessel for preservation, the saved animals, a landing on the mountain, birds sent to explore, a sacrificial thanksgiving, a new beginning. These details recur across cultures that had no apparent means of sharing stories. Is it possible that all these cultures independently invented the same narrative structure? Yes, it is possible, but the degree of convergence is striking, and it offers an alternative explanation. What if the flood myths are not independent inventions? What if they are memories? Not memories of a single global flood that happened simultaneously, as physics doesn't support that. There has never been enough water on Earth to cover the entire land simultaneously, but memories of a process, a prolonged and devastating process that affected coastlines and river valleys around the world over thousands of years. At the end of the last ice age, starting around 15,000 years ago and continuing until about 7,000 years ago, global sea levels rose more than 120 meters, nearly 400 feet. Coastlines that had been stable for tens of thousands of years were submerged. Entire landmasses disappeared. The land bridge of Beringia between Asia and North America, the land connection between Britain and Europe, the vast Sundaland continental shelf between Southeast Asia and Indonesia, the continental shelves of India, Australia, and the Americas, all submerged. The geographical transformation was immense, and it didn't happen gradually everywhere. While the overall trend was slow by human standards, it was punctuated by episodes of rapid flooding, melting water pulses, sudden releases of enormous volumes of water from collapsing ice sheets or breaking glacial lakes could raise sea levels by several meters over a few decades. For coastal populations, this would have been catastrophic. Imagine a community living on a coastal plain 12,000 years ago. They've lived there for generations. The sea is their provider. Their culture is built around it. Then, the water starts rising slowly. At first, the beach gets closer. Camps have to be moved. Then, faster. A storm comes, and the sea doesn't recede. Fields are flooded. Wells become salty. In the course of one lifetime, the land their grandparents walked on is underwater. And in just a few generations more, there's no memory of it, except a story. A story about a time when the water came and took everything. And here's the final twist. If there was a civilization before ours, a civilization that existed during the Ice Age when sea levels were 120 meters lower than today, where would it have been? Not in the highlands, not in the mountains. Civilizations settle along the coasts, along rivers, along trade and travel routes. They would have been on the continental shelves, the same land that is now underwater. We haven't looked there, we've barely begun. Marine archaeology is expensive, difficult, and of limited scope. The submerged landscapes of the last ice age remain almost completely unexplored. Thousands of square kilometers of land that was once dry land, habitable land, coastal land, remain beneath the waves, unexplored. If evidence of a lost civilization exists anywhere, it's there, underwater, under the sediment, under the silence of 12,000 years of ocean. Let's take a pause here and talk about why this question is so difficult to answer. Not the question of whether a previous civilization existed, the question of whether we could find it if it had existed. Because Earth is not a museum, it is a machine that grinds, dissolves, subducts, melts, compresses, and erases, and it has been running for 4.5 billion years. Consider what would happen to our civilization if it ended tomorrow. Not in a nuclear war, not with an explosion, just a quiet exit. Humanity disappears. The machines stop, the lights go out. What happens next? Within weeks, most electrical grids fail. Within months, vegetation begins to reclaim cities. The roots crack the pavement. Vines climb up the walls. In decades, wooden structures collapse. Steel rusts, glass shatters under thermal stress. The buildings we thought were permanent begin to crumble. In a few centuries, most structures above the ground disappear, reduced to rubble. In a few thousand years, the rubble is buried beneath the earth and sediment. Within 100,000 years, the last remnants of our cities are geological layers, thin bands of unusual chemistry in the rock, fragments of concrete, microplastics, elevated levels of heavy metals, a spike in radioactive isotopes from our nuclear tests. Within 1 million years, tectonic processes have resurfaced entire regions. Rivers have changed course, coastlines have shifted, mountains have risen and eroded. The specific locations of our cities are no longer identifiable from the surface. The only way to find them would be to drill or stumble upon an exposed cross-section, a cliff or a road cut that happens to intersect the thin layer where our civilization once stood. Within 10 million years, most of that layer has been subducted, eroded, or metamorphosed beyond recognition. Tectonic plates have dragged parts of our continental shelves into subduction zones, pulling them into the mantle where temperatures and pressures melt everything into magma. Chemical signatures persist in some places, anomalous layers of carbon, nitrogen, and trace metals in sedimentary sequences, but they are subtle, ambiguous, and in many cases indistinguishable from natural volcanic or hydrothermal events. Within 50 million years, virtually nothing physical remains. No structures, no artifacts, not a single fossil of a human being, because the conditions required for fossilization are rare, and the fraction of any species that becomes fossilized is infinitesimally small. Dinosaurs dominated the Earth for over 165 million years, and the total number of individual dinosaur fossils ever found would fit in a single museum. A whole civilization that lasts only a few thousand years would be lucky to leave a single fossilized individual. What remains are chemical whispers, isotopic ratios, thin layers of unusual concentration in deep ocean sediment cores, the kind of signals geologists find all the time and attribute to volcanism, methane releases, orbital changes, or other natural processes. Because until Frankenschmidt asked the question in 2018, no one was looking for anything else. This is the fundamental problem with the Silurian hypothesis. Earth is not just vast in space, it is vast in time, and time is the great eraser. Given enough of it, the planet will destroy the evidence of almost anything that ever happened on its surface. Less than 1% of Earth's surface is urbanized today. If you were looking for evidence of our cities 50 million years from now, you would be searching through core samples representing less than 1% of the original surface area, most of which would have been recycled by tectonic processes. The odds of finding a direct artifact, a piece of concrete, a fragment of steel, a piece of glass, are essentially zero. You would have to rely entirely on indirect evidence, chemical anomalies in the rock, and these anomalies, as we've discussed, could look exactly like natural events. Now consider the oceans. 71% of Earth's surface is water. The ocean floor is not permanent. It is created at mid-ocean ridges, where magma rises and solidifies into new crust. And it is destroyed in subduction zones, where old crust sinks back into the mantle. The oldest ocean floor on the planet is about 200 million years old. Everything older than that has been recycled. Any evidence of anything that happened on the ocean floor more than 200 million years ago has been melted back into the interior of the Earth. And then there is the sea level. During ice ages, when vast volumes of water are trapped in continental glaciers, sea levels fall dramatically. During the last glacial maximum, about 20,000 years ago, sea levels were about 120 meters lower than today. The coastlines of every continent extended far beyond their current positions. But taken together, these anomalies form a pattern of things that are slightly out of place, slightly harder to explain than they should be, and slightly more connected than they should be. A pattern that invites, although it does not demand, a different kind of explanation. Imagine a civilization that arose during the Ice Age. Not our kind of civilization. Not one that burned fossil fuels and built nuclear reactors. A different one. One that developed along different technological lines. Perhaps more maritime than terrestrial. Built along the coastlines of the Ice Age continents, where the climate was mild and the seas were rich. A civilization that developed astronomy, navigation, agriculture, architecture, and social organization, but left a lighter footprint than we do. A civilization that understood the earth and the sky in ways we are only now rediscovering. Imagine that this civilization was struck by a catastrophe, a comet impact, a sudden climate shift, the rising seas that drowned its coastal cities, fire and ice and flood, all within the span of a few generations. Not everyone died. Some survived. Some carried the knowledge with them, fragments of astronomy, agriculture, navigation, engineering, and they spread across the world, teaching what they knew to the hunter-gatherer populations they encountered. Imagine that these survivors built Göbekli Tepe as a memorial and a repository of knowledge. That they carved the Sphinx as a star-aligned marker at a specific moment in time. That they passed down stories of the catastrophe, stories that became the flood myths of Sumer and India and Greece and the Americas. That their maps, their charts, their understanding of geography filtered through millennia of copying and recopying until fragments of impossibly accurate information appeared on a gazelle skin map in 1513. Imagine that the evidence of their coastal civilization lies exactly where you would expect to find it, under 120 meters of ocean, on continental shelves that we have not explored, in layers of sediment that we have not examined, in the gaps of a geological record that we have only just begun to read. This is the story that researcher Graham Hancock has been trying to tell for decades. And it is a story that conventional science overwhelmingly rejects. The rejection is not unreasonable. Extraordinary claims require extraordinary evidence, and the evidence though suggestive, is not extraordinary. It is circumstantial. It is interpretative. But the rejection is not the last word either, because science is not static. It is a process, and the process involves testing hypotheses, gathering new evidence, and revising our understanding when the evidence demands it. The Silurian hypothesis was published in a peer-reviewed journal. It was not a conspiracy theory. It was formal scientific research into the limits of our knowledge. And its conclusion was not that a previous civilization existed. Its conclusion was that we cannot rule it out, and that admitting what we don't know is the first step toward discovering it. You won't see it with the naked eye. You have to know where to look. You have to understand the language of deep time. You have to realize that the Earth keeps its secrets in chemistry, not in monuments. But if you find it, if you identify it, if you sit with its data and compare it with what we are doing right now to this planet, something happens. Not exactly a revelation, rather a shiver of recognition. The feeling that the line between the past and the present is not as clear as we thought. That time is not an ascending ladder from simplicity to complexity, from darkness to enlightenment, from beast to civilization. That it is something more circular, more strange, more unsettling. The Earth is 4.5 billion years old. The conditions for intelligent life have existed for hundreds of millions of them. We have existed for an infinitesimal fraction of that time, as a civilization, for a fraction of a fraction. And yet, we confidently claim that we are the first, the only ones, the only intelligence experiment that this ancient planet has produced. Maybe we are. The simplest explanation is that we are. But the Earth does not respond to simplicity. It responds to processes that were happening long before we arrived, and that will continue long after we leave. It turns, it drifts, it erodes, it subducts, it recycles. The record of what has ever been here is incomplete. It is full of gaps the size of empires, and we are just beginning, barely taking the first steps to learn how to read the gaps. What we find there may confirm everything we believe, or it may forever change the story we tell ourselves about who we are. The pyramids survived 4,000 years because they were built on rock and in the desert, far from the coastlines that were flooded. The Sphinx survived, whatever its true age, because someone carved it from the bedrock. Göbekli Tepe survived 12 millennia because it was deliberately buried by the people who built it. And the flood myths survived because they were too important to forget. Those who built these things, whoever they were, understood something that we are slow to learn. That time destroys everything eventually. That if you want to be remembered, you have to build something that time cannot touch so easily. Not necessarily in stone, sometimes in history, sometimes in science, sometimes in the way you treat the planet you inherited and that one day you will pass on to someone else. If someone existed before us, what did they want us to know? And if no one existed, what do we want to leave for those who come after us?